Hey everyone, hope you've had a wonderful start to your term three. I myself have had a busy start, so apologies for releasing this crash course a bit later than the other ones. But yeah, I hope you all are enjoying 3101 so far. I believe you have, well, would have started something to do with like network and network analysis by now. Um, but in this crash course, I'll still go over from start to finish, just briefly going over the content that you learn in 3101. And also, there will be some questions here and there. I probably won't have enough time to actually go through the questions. But the questions that I have put into this crash course are essentially, well, actually are workshop questions. So they have their own set of worked out solutions. But I'll just be going through with those questions the sort of like ways to approach them and make it easier to understand when those questions come up either in the exam or um, in like a quiz environment. Um, you might have guessed by now, if you have been listening into lectures and doing some of the week one tutorial content, that this course is a lot of content, um, and it's going to get worse. Unfortunately, this course is very much theory dependent. Um, Compared to, say, I think some of you would be doing soils this term as well, 3202, where that course is pretty much almost all like math. This has like some math, but majority of it is yeah, just words and words and words. So that's why for this crash course, I'm only going to go briefly over the content. I'm sure Mosin will be able to explain in much a deeper level of what each of what I'm going to tell about now. He'll go through much deeper, in a deeper level. So yeah, without much further ado, what will be covered in this crash course, as I've explained before. First up, we'll just run through essentially what the assessments look like and what the course looks like as well. I've then split up the crash course into pretty much before the midterm and after the midterm, because I just feel like you would prefer if it was split up that way. I believe because at least from when I did the course, the final exam part did not assess content that was already assessed in the midterm. So this way, I think it would be better if you just had everything clumped together that was for the midterm, and everything for the final exam was then clumped together in its own section. Um, and then finally, once we go through all the content, I'll just do some tips and tricks that I think is beneficial if like you're like studying the course as well as maybe cramming towards the end of exams, like what things you should be looking out for and how you should prepare yourself. And also on the left hand side, you'll see on almost every slide this sidebar that goes from 1 to 6, and that 1 to 6 is essentially what um, is how this crash course is being split up from assessments all the way down to tips and tricks. So yeah, we'll start off with the assessment structure. Based off what I have seen on your guys' Moodle for this year, it's pretty much the same structure as what previous years have had with Merson. Um, I think Merson would have probably gone through what assessment one is about. But just to jog your memory, assessment one is to essentially choose a location where something is being built, or like a project. I think there are like specifications of how big the project should be, but essentially you have to pick that project and then like analyze it for its, I believe, uh, it's like its processes. I think there's contracts in there as well. Um, but yeah, like the brief should have been released anyway, so that should have all the information on it. Due dates, I also believe, are the same. Though these due dates that I have on here are pretty much what we had from when I did the course, but I think they should be very similar. Um, your midterm as well, same weighting as before. Um, and week 5, I think it will be during a lecture, so just be mindful of that. You might need to attend that lecture period that is for you guys to be able to do the midterm. Final exam, previous years it has been open book. I have heard from some of the people doing the course this year that it's also open book for this year as well. So that's good news. Um, and essentially, I've kept that in mind as well with this crash course. Essentially, I feel like majority of you will be exploiting that um, the fact that it is open book. And so essentially, this crash course won't have as much information because it will still have like the content that is from the lecture slides and that, but you're more than welcome to just bring in, I guess, workshop answers, I guess, to the final exam, to be able to just use them as freely as you want. I personally found that when I was doing the final exam, that the workshop solutions helped me like write out the solutions during the final exam, made it much more like streamlined for me. But I'll go through the rest of the tips and tricks later at the end of this crash course. Also, another thing to keep in mind, I know a lot of people um, not look at this when they're calculating their marks for the um, subjects. This hurdle for 3101 is a little bit different compared to the other like core engineering courses. So I know previous ones they have that 40%, you have to get 40% in your final exam for the rest of your pre-exam marks to count. 3101 and I believe 201 also work a bit differently. So you have to just make sure that you get a 50% at least in both your midterm and final exam. And then with that, then you'll be able to pass the course. Um, the course outline and structure also I've seen is pretty much similar to what previous years have done. I think there was just a name change here and there, but the general essence of what is taught in this course hasn't changed at all. The actual names of the modules are very like good explaining what each module is about. Um, I don't know too much about how, like, what Merson has been teaching per week, but I believe it should follow this sort of structure. Essentially, each module does correlate to 1 week's worth of teaching. Um, I think here and there it just depends on like when the public holiday is happening. I've also put on the right hand side the difficulty that I think each module poses to students. Um, yeah, like the way that I've put it is the more math side of this course does make it a bit harder. So, like stuff like engineering economics, for example, I would say it's a bit harder to wrap your head around. But the more theory part of this course doesn't get assessed as much, I would say. Like, yes, it does get assessed in the um, final exam and maybe the midterm, but it's not like, given that the exams are most likely to be open book, it's a bit easier to just kind of read off it, I guess. So that's how I kind of split up the difficulty that I think this course poses. But yeah, like again, this is completely your like how you view the course. Like, if you feel like you don't agree with this, I completely understand. This relative difficulty is what at least I would say would be the case. All right, let's start with the first module. I'm sure you guys will think, this is very familiar because you've done this already. But just, yeah, to give a quick recap, you could say, for what is project management. I split this up into like the bare bones of what each module is about. This is for like all the following modules as well. So, um, yeah, we'll start off with again what project versus operation is about. Um, this image is pretty much copy pasted from the lecture slides, but I did make some changes with how I've added in examples of what a like a different examples of what a project versus an operation looks like. So yeah, like the project is more so the like it has a defined end to it, but as an operation it just can just keep happening repetitively over like a longer time. And yeah, the differences between project and operation in terms of examples is that you have like a highway being built. That's a project, but then once that construction is complete, that's when the operations are more likely to start, where you have to manage the highway, maintain it, ensure that like it's still suitable for its requirements, like in terms of traffic and environmental concerns. And then there's other examples as well, like with apartment and like land remediation as well. And I've sort of like correlated them to what sort of operation will like follow that project essentially. Um, and then I think, yeah, next thing that was discussed in module one was project life cycle. You should be familiar with these 5 stages of the project because they will come up a lot in tutorials, exams, all those sort of things. One good way when this like life cycle does come up as a question, and you have to explain like the different like state like components of each of these stages. A good thing to note is that if there's a component of, let's say, planning, that component can also follow on to like execution. It's like the same thing, but it's to do with the execution. So it like each of the components of each of these stages, literally like it's just a change of wording that you can just put and say like, okay, we start off with the initiation, and then that particular component then follows into planning and then into execution. So if you ever need to explain like a particular project and how it develops over through this life cycle, you can sort of follow that sort of structure in your response. Um, it like that won't be the case for all 5 of these stages. Like it only may apply to like 2 of them or 3 of them, but that will still get like you marks for being able to relate a component from one to another, from one stage to another. Um, and then this project management knowledge areas is very theory based. I kind of found this to be a bit more so like common sense sort of thing. But yeah, this sort of like these knowledge areas are essentially to do with communication and the timeline of the project. So being able to know how long a particular thing takes and what sort of action you would need to take as a result of factors that are affecting it. And as long as you'll be able to know these from a like basic level, I think it's pretty easy to then just branch out in terms of the specifics of like maybe like who the stakeholders are for that particular question, or what sort of costs are required for that project. Like you can go into more detail Like, is it related to equipment cost, or is it related to um, the, what's another example? Material cost. So those are the things that you'll be able to elaborate more on if the question requires you to do so. Project management tools, you may be familiar with some of these already, but 3101 does introduce you to a couple more. You probably are familiar with what a Gantt chart is, and maybe you will be familiar with what a CPM, or critical path method, looks like. But I think, yeah, the two main ones that are introduced are the work breakdown structure, WBS, and the PERT. I can't remember off the top of my head what that acronym stands for. Um, but yeah, what I just put on this slide is essentially the purpose of each. And essentially, in reality, these tools are generally like all of them are used to some extent for like large scale projects, but the sort of stuff you'll be dealing with in this course is only maybe like just one of them. You're not going to deal with like two sets of project management tools within the same question. They only ask you about one. I've seen a lot in regard to the PERT sort of management tool. But there's definitely instances where I've seen WBS, like essentially the new ones that you're not that familiar with, they're going to ask essentially. But that doesn't mean like you still would familiarize yourself with Gantt chart and CPM in the context of construction and this course. So I'm not discouraging you from looking at those once again. But yeah, I think at least for me, when I was doing this course, I would probably spend a bit more time, like compared to the other ones, spend more time looking at WBS and PERT. Cool, that was module 1. We'll move on to module 2 now, which I believe you also would have started looking at by now. So essentially this module looks more into the way that it's similar to what the CPM, the critical path method, is, but it's just applied to pretty much every project, and how you can use that network to describe the timeline of that project from start to finish, and every other component, factor, aspect that can influence that timeline as well. So you probably would have seen the sort of networks that is in like a critical path method. We'll get to actually what is the critical path for this thing in the next slide. But just to describe the sort of networks you deal with, there are two main ones, activity on arrow and activity on node. The big difference you can see is the activity on arrow, they have the milestone or the stage that the project is at. That is where the nodes are. And then the arrow itself is how to get from stage to stage. Whereas the activity on node doesn't have that, it doesn't have anything on the arrows. It's just from one node to the next node. And it's just, the arrow is just to say, go in this direction. In the middle of the screen, you have FS, SS, FF, and SF. Those are the ways of going from one node to another node. So FS is finish to start, i.e. the method of going through this network is that project B, activity B can't start until activity A finishes. So it has to flow on from that path. SS, start to start, means that activity B will start when activity A starts. And so, yeah, and then FF, finish to finish, means that yeah, activity B can't finish until activity A finishes, and then SF is essentially like the opposite of FS. So yeah. Lead time, lag time, and neither. So lead time is having the. So I don't have my pen with me. So I unfortunately can't use it to explain this, but I'll try my best with words. Um, so if you have like activity A and activity B, and you're going from A to B, lead time just refers to their the fact that activity B can start before activity A finishes. So this is different to FS, SS, FF. This is just like this lead time is just how it looks like on a network, um, or how it's shown in like a table of data. So lead time is where activity B can start before activity A finishes. Lag time is essentially another way to describe lag time is that there's a particular time of lag between where activity B starts and when activity A finishes. So like, let's say activity A finishes on Wednesday, but activity B starts on Friday. So there's a lag time of 2 days. And then neither is essentially where activity A finishes, so activity B starts on the same day that activity A finishes. So they like activity A finishes on the Wednesday, and like activity B starts on that same Wednesday as well. So there's neither a lead time nor a lag time. Most of the scenarios you will deal with are the case of neither, but in the case where there is a set of lead time or a set of lag time, that will be shown on the arrow in that network. So I believe, if I recall, lead time should be a positive number. So, sorry, no, lead time is a negative number. So if activity B starts on the Monday, but activity A finishes on the Wednesday, there's a lead time of -2, and that will be written on the network um, that is shown on the page when you're dealing with that sort of question. And then lag time is the positive version. So we'll show like a +2 for the case of finishing Wednesday, starting on Friday. Dummy activities is also another thing that you might see every now and then. That is just to show that it can either be a starting dummy activity or an ending dummy activity. It's just to show that the path from a particular activity still is part of the network. Even though the activity may not be related to any other part of the network, it's just there as like a terminus or like a start for that particular node. And it's just a good way to show that the activity is still relevant for that network, and it still exists and you shouldn't forget about it. All right, moving on to network analysis. So what I've shown on screen is essentially a completed network once like pretty much most of the analysis has taken place. So essentially the ES, EF, LS, and LF stand for early start, early finish, late start, late finish. And that's essentially what the um, depending on what the how long an activity takes, that's what determines the finish of that activity, the start of the next activity, and the like finish of the next activity. So that's how you move on from node to node, and you have to do all of that to be able to complete the network, because you can like it's a like a way to like check that the path that you've drawn is correct. And that's where the forward pass and backward pass comes in, because the forward pass is going from start to finish. That is generally how you would normally work. Like you would go, okay, activity. So you go from start and then activity A, which in the brackets it says 4. That's how long the activity takes um, to complete activity. So it would take let's say 4 days to complete that activity. And then you would move on to, let's say, activity F, which takes 10 days. So you can only start F after 4 days from the start. And then F takes 10 days to complete. So after the 14th day from start, activity F finishes. And then you would do that sort of thing for the rest of the network. And then, yeah, so when you come to, let's say, activity G, where there's essentially the path start AD and also start CE going into activity G. The number that you need to take for the earliest start, the earliest start that G can start at, has to be dependent on the latest finish possible. Sorry, the earliest finish. My bad. Earliest finish. So wait, am I confusing myself again? Um, so activity G can only start once the activity previous has finished the last. So if you look at activity E, for example, that finishes on the 5th day from the start because it has gone through 3 days activity C and then 2 days at activity E. But if you look through the AD path, that has gone through 9 days since the start. It's gone through 4 days at activity A and then 5 days at activity D. So activity G is dependent on both D and E, but it can only start once D finishes because E is finished within 5 days, but you still have to wait another 4 days until activity D finishes. So G can only start once D finishes. And then that's why G can only start on the 9th day, and then the finish is also dependent on activities F, G, and H, which then you have to take the latest finish, which is G again, which finishes on the 16th day. So therefore, the entire project, for example, or this network, which may resemble a project, that entire network finishes on the 16th day of the project. So that's the forward pass. The backward pass is you essentially doing the forward pass but in reverse. So you would start from the finish and then branch out and then ultimately reach the start. And you would stay like the start is the finish for the backward pass. The critical path, you've heard me say that multiple times now. This is where it comes into play. Critical path is the path that ensures that every task is completed, but the sorry, every task is accounted for in terms of how long it takes to do it, and the path itself is the one that essentially where every activity on that path takes the longest time to do. So that's a good way to know what is the critical path. And then yeah, that is useful for follow-up questions with how to like how long this project needs to take, because the length of the project based on the network depends on how long that critical path takes to complete. Dangling activity I'm not too familiar with, so I might skip that for now. I'm sure Mohsin has gone through it in his lectures, so you can look through that. Um, and yeah, same with float, like with TF total float and FF free float. I don't have the notes on me right now, so um, you'll be able to see what they are on the lecture slides themselves. Sorry about that. Okay, moving on to crashing. So this is nothing to do with car crash compilations. But this essentially crashing is reducing the time of the project at the expense of the project's cost and or its quality of the product that that project is working on. Some projects will use this method of crashing to essentially speed up and meet um, deliverables earlier and be able to essentially make up for lost time if there was any like disruptions here and there. So some of the methods that projects will use to as part of the crashing technique is making or giving the opportunity for employees to work overtime, as well as also implementing like faster installation methods to, yeah, again, speed up the process of construction. Just a note, crashing can only be applied to critical paths until they cannot be further reduced in time. So I've included on the slide a picture of um, what will be seen as like um, the particular paths that are possible for a project. So paths such as ADG, BG, CH, and the sort of like table that you would use to see which activities would you crash to like speed up that like the duration of that activity. You'll become more familiar with these when you go through tutorial questions. Um, and also probably during the lecture as well when Mosin goes through it. But essentially, you'll be looking at a lot of iterations of which path could be crashed further, and essentially reducing it one by one until you can't crash it anymore. So it is a bit of a lengthy process, yes, and sometimes you will get asked that question, and it's a bit of a pain to go through that process. But it's repetitive, so as long as you know how to solve that question, it will be completely fine. And yeah, in the top right hand corner, that's just the equation to use when solving the process of crashing. I can't go through that explanation right now. It's a bit of a lengthy talk. But yeah, that is a useful equation to use when completing questions about crashing. Alrighty, engineering economics is module 3. This is where stuff gets to get a little bit harder with in terms of the sort of math that is required to complete these sort of questions, because now we're straying away from like visual representations and theory and coming into more like scenario based solve this question sort of questions. All right, so just a general overview of what engineering economics is in this course. It is just it's just a set of estimation or calculations for design alternatives and their associated costs. And generally, the way that these costs, like the reason that these calculations are made, is in order to minimize costs and maximize profits for, say, a company if they're trying to come up with like which like vehicle to use depending on its like um, its price, for example, or if there's like a set of emissions that that vehicle produces that translates to a particular cost, for example, like which vehicle would be better, and in what way will that company be able to minimize the costs to like depending on what vehicle they choose, for example. Um, yeah, so these sort of questions that will come up in sort of like module 3 questions, they do require like a very structured step-by-step set of calculations. Um, again, they do become a bit more repetitive, but sometimes you will come across questions that does require like um, a bit more thinking to know which like calculation to make, for example. Engineering economics, yeah, is mainly used for profit, as I said before, and also just like choosing the right equipment or the right project to work on, and also for project expansion, like should this company go ahead with completing this expansion? Like, for example, should the Sydney Metro expand towards like further on from Bankstown? Like that could be something that um, could be um, put in this course. It probably won't because it's a bit too complex, but that sort of like project expansion sort of idea is what I'm going for when I say that. So when you look at the like economic measures in construction, these are the sort of like you will go through initially the like loan payments and interest rates, those sort of things, when it comes to like if a company needs to take out a loan for a set of equipment that they need to use, or if they are going to need financing for a particular period of time for their projects. So these sort of questions that you initially be working on for engineering economic measures. Um, I put this in red. Make sure it is make sure the interest rate is converted to decimals form, because that has tripped me up a lot of times when I do questions like these. And I know in the rush of exams, you may also do the same mistake. Um, but yeah, also just the different types of cash flow that you'll be introduced in this course. You start off with what is called single payment, but essentially is the sort of stuff that you might have done in high school with simple and compound interest. They just use different like words for naming purposes in engineering, but you'll see stuff like present value, future value, interest rate, and like number of years, like those still stay the same. It's still the same concept of compound interest or simple interest depending on the scenario. But what is new is equal payment series and linear gradient payment series. And that is just, it's very engineering core. Um, it's very similar to the interest like side of like how sorry, with the payments done like let's say annually or in a set period of time, but it's just like yeah, equal payment is just pretty much your like linear like set amount each like every time. And the linear gradient is, as you can probably tell by the picture on the screen, it just like, yeah, increases or decreases depending on the gradient that it follows. The actual calculations for it will be gone through in the lecture. This just here, what I've put in here is just a general overview of what sort of stuff you'll be introduced to in the lecture. All right, this is probably a new thing for you all. Project appraisal methods. The appraisal itself is essentially how much the project is worth and its related investments, how much of those worth. And so essentially in 3101, there's different methods that are used to essentially look at these, like how much things are worth. They have their own calculations as well. As I said, this is a very calculation-based module. But yeah, I've included from the lecture slides as well this picture, which shows like which method to use depending on the situation in like the scenario. So yeah, the B stands for like benefit, C stands for cost. So if the benefits, like B minus C just means if the benefits are more than the costs, then it's better to use the NPV method, for example. Um, and then yeah, so each method has their respective advantages and disadvantages. Those are covered in the lecture. I would suggest being familiar with those because they may pop up some like in the maybe the midterm, just depending on what is assessed in the midterm. So um, yeah, just to let you know. Oh, all right, so yeah, that's essentially everything from module 1, 2, and 3 condensed and briefly talked about. So I've put in here questions from the workshops that I think will be most likely assessed in um, maybe the midterm. So I don't have answers to these, as I said previously, but there are answers available. I think, yeah, this WBS thing is the answers already, but yeah, these are essentially what is available in the workshops, which has their own set of solutions, but I've just put in here because I think these are good questions to like work on and practice on for the midterm, and then the at the end when I do the same sort of thing for the final exam, like that's what I would think is good to study for the final exam. So example questions from module 1. Yeah, so these are, you've got on the left hand side WBS setup, and then the PERT setup on the right hand side. And questions from module 2, you have, yeah, you're just being told to draw the activity on arrow and activity on node networks and complete that set of doing the boxes of like the numbering from the early start, late start, early finish, late finish, that set of the box on here. And then also, yeah, finding that critical path. I think it also had dangling activities. Sorry, I can't explain that right now. But yeah, and same with TF and FF. Those are talked about in the workshop solutions, so you'll be able to look at those. And then also the in the bottom right hand corner with the crashing scenario, yeah, that essentially, as I said, it's a very iterative process, but it should be able to, like, you should be able to work through that because it is just a bit repetitive as well with how to do that. And then, yeah, from module 3, these, we've got essentially a sort of compound interest scenario going on in question 5, and then question 9 is yeah, it's an NPV scenario. You would learn more about this, like which one to um like which appraisal method to use. You'll be like taught that in the lecture, and then you will see, okay, based on the variables in this question, okay, I'll need to use this appraisal method. And then, yeah, for different, like generally, NPV is the most common appraisal method for these sort of like module 3 type questions. Haven't seen too much of the other ones. I think maybe, I think IRR sometimes comes up every now and then. Um, but yeah, more often than not, you'll be asked something to do, like that's a question, and then it's most likely that you'll be using NPV like calculations for that. Okay, so moving on to what is past the midterm, you're going to what will be assessed in the final exam. Start off with contract management. So we'll be going through here the contract management phases, project delivery systems, contract types. So project delivery systems and contract type are two different things. Um, they may seem like similar when you go through the content for them, but just be wary that they are different. And then finally, dispute resolution, because that's the sort of stuff that you will need to know about when like two parties, two companies or two whatever have to deal or negotiate or work on a contract to be able to use for that project. Um, because yeah, a project does take a lot of time to complete. So you have to make sure that the contract is something that everyone can agree on. Alrighty. I've just summarized the contract management phases here and the sort of like actionables are required for each of these stages. So, in the contract management planning phase, essentially what is being looked into by each of the parties or companies is the key performance indexes, um, being able to arrange meetings between the parties to be able to agree on like to do those preliminary um, like contract building things. Risk management plans are also thought of in this phase, and then also just resolving those initial, um, yeah, like based on the meetings that you've created and the RMPs and the KPIs, you would want to resolve those disputes like as early as possible to then not have to worry about them when the contract is up and running and the project is up and running. Contract startup is the next stage where essentially you're just confirming that everything's set to go, it's good to go, the project can start. And then that's also when you distribute the assets accordingly based on the, the capabilities of the different parties, and also establishing that concrete set of communications like, okay, we'll be using like email or we'll be using um, like I don't know, walkie talkie, like those sort of things that you should be able to have in place and not have to worry about. And that's essentially the purpose of the contract to say, okay, the contract says this, therefore we need to do this according to the contract. And then the stage after startup is performance. You track the performance of the contract. So essentially, that's where you're managing the items from the first phase, and just monitoring how that contract is being, um, like, what's the word? Um, adhered to. And that's when you like if you see any like hiccups that are going on, that's when you like raise concerns or raise questions with the other party to ensure that everyone's still on the same page and that everyone is like if there is any issues, that's when you probably would want to go about resolving any more disputes again, because again like whenever you would want to resolve disputes as early as possible so that it's not affecting anything with the timeline as seriously. And then finally, contract closure is when the project is over. So that's when, yeah, all the other phases are complete. The project is can be handed over to the next party that it needs to work on it. Same with the contract itself, that can also be handed over depending on what is in the contract. Also, this is the time to then also look over and see, okay, what did we do wrong? What lessons can we learn from this? What can we take on moving forward? And stuff that maybe for the next contract that you write up, when you go about the next contract management planning stage, like, okay, from this previous contract, we saw this. I think we would need to put this into the next contract that we make. So those sort of things are what you would see in a contract closure phase. All right, project delivery systems. These are the 5 PDSs that you will be going through in this course. Essentially, these systems just describe the sort of like hierarchy, you can say, with the communication levels of like who should get involved with the different like phases or stages of the project. Like one way to compare it is like if you're in a society, like a student society, and you have to communicate with, say, a company or industry to invite them to an event, like what sort of communication methods you would need to use to action on the items that they would need. Like, for example, would you ask the subcommittee to talk directly to the industry representative, or would you rather have a director get involved to do that sort of communication? And that's what this sort of set of PDSs, there's like so many options that you could have depending on what requirements are needed for that project. So the these 5 are will be assessed in this course. Like, I don't think, I think maybe BOT is the one that's not really talked about as much. But the main one, if there was one that like is talked about the most, it's DBB. That's the one that most like yeah in real life most projects use that PDS. The B that stands for bid is probably what you would see most often in the workforce. That's if you might have heard that like um, some companies they bid to be able to work on that project as like a contractor. So yeah, that's where DBB comes in more often. DB is like yeah, you don't have to go through that bidding process essentially. Like it's just a set thing. Each of them have their own advantages and disadvantages again. Those are talked about in the lecture by Mosin. I currently can't put that in the crash course now due to time and the fact that it takes ages to explain. But yeah, just familiarize yourself with these 5 PDSs. They will come up in exams with maybe having you to describe each scenario, or even having to choose which PDS works best given a scenario. I do have an example of that. It's in these crash courses, but also came from the workshop slides, workshop handouts, so you'll be able to see the thinking process for whichever PDS is required. Contract types. This is different to the PDSs, as I said. I don't have too much information about this because these also take a while to explain. But the main 2 types are fixed price and cost plus. Yeah, so the contract types are just the sort of yeah, this is more so for the financial side. Like you don't have to do any calculations for these. These are just to show wait. There's like small calculations you need to do, like just basic addition and subtraction, for example. Um these sort of stuff are just like to describe the contract itself. Like um the sort of like if there was a change to the contract that is required, like quantitatively, then how would you implement that depending on what type of contract it is? And so you would need to see, okay, based on this contract, you'll be able to do this subtraction or this addition, and then that will change the contract accordingly. Off the top of my head, I don't think you need to do any like analysis of it. You just need to maybe do a calculation here and there. So, yeah. that works for that applies to both fixed price contract as well as cost plus contract. So just keep in mind when that comes up in the lecture. And then yeah, the last thing for this module is dispute resolution. Now, the way that it's been told in the slides is pretty much in order of preference. So the first step for dispute resolution would be to negotiate because essentially it is the cheapest solution to do, and it should be your first choice. You would only move on to number two if number one doesn't work. So number two is escalation, where you forward it to someone senior in that team or in that company. Number three is mediation. It still can be done internally, mediation, where you instruct both, not you, but like someone else that's not directly involved in the issue. They just like mediate the process so that both parties can come to an agreement by themselves. But then if mediation still fails, that's when things start. You would have to like those two parties would need to reach out externally to get access to someone called an arbitrator to do the arbitration process, where the arbitrator will then come to a decision on behalf of the parties, and then whatever decision that arbitrator comes up with, that has to be strictly followed. Obviously, getting someone externally to come and do something for you requires them to be paid, so there is an expense that you need to take on for that arbitration. But then finally, if worse comes to worse, whatever the court says, you have to follow. So that's why litigation is the last resort. This also is the most expensive solution, as you probably would know from watching the news. The sort of money that gets thrown around for court cases. But yeah, so if there was like a scenario where you would need to go off the sort of like stages of dispute resolution, this is the setup that you would follow from best case scenario to worst case scenario. All right. Conceptual cost estimating, another mathsy module. This one is to do more so with the project, the project's components and its associated costs. And these are sort of like just loosely broken up into different areas. So, for example, material cost, equipment cost, operating cost, and even that is also then broken up into stuff like fuel cost. That I'll explain in the following slides as well. But yeah, these are just loose terms to describe like very basic terms. Like you're not going to be looking at very like detailed cost estimating essentially. So yeah, there's like levels of accuracy when doing this cost estimating that you will go through in questions based on what level they are, like what the question is saying the situation is at what level, like sorry, in what level is that scenario in. So level one, for example, is just like the preliminary stage, like the the first stage. Level two is the completion of the preliminary design, and level three is the final design. So depending on what level the project is at, like at what point the project has been completed, that determines how accurate the cost can be determined. And that's shown on the graph on the right, that from going left to right in terms of time, the accuracy just gets better and better um, towards the end of the project. To be able to actually forecast the costs of the project depending on previous projects, that's when you would use the formula in the middle of the screen. Um, and that is just, yeah, based on historical data that would be given to you in the question. You won't have to like outsource it. And yeah, it's a basic um, equation to follow. Um, yeah, it's not much more to say about that. All right, so the again, continuing on the idea of like looking at previous projects and historical data, sometimes you would need to adjust the situation. Sorry, you have to adjust the costs based on the previous situations. And one way that you can look at previous situations is based off something called the engineering news record. Um, and that's not like it's always given to you in the question. You don't have to outsource it. Um, but it depends on what sort of adjustment the question is asking you to look at, or like what that scenario is asking you to look at. So, for example, if you're looking at a scenario and trying to find out how that sort of project went in previous years, like if that project was built 3 years ago, what sort of costs were involved, for example. And that's when you would look at the ENR and look at the time adjustments. So you would look at the index that's related to time, and you would see, okay, 3 years ago, um, it was this value, and then compare it to currently. Okay, so yeah, there's this difference that I see, and you would then need to do that sort of calculation based off the differences in the index that you see from the ENR. There is a process of actually doing that calculation that will be talked about during the lecture. Similar scenario with location. Obviously, it's different to time, so you're not going to have a current year. You're more likely to just be, okay, like currently you're building a um, hospital at city D. Okay, now I can look at neighboring cities like city A, city B, and see the sort of costs that are required for those surrounding cities, and then be able to then say, okay, for city D, this is the sort of um, like costs that are required. Um, Size adjustment, that is just a simple ratio. You don't need an ENR for that. That does not have an ENR associated with it. Size adjustment is pretty much similar to how like similar triangles work. Like it's just that same ratio sort of thing. All data will be given in that question, and then you just need to do just a simple ratio. Again, all these three, there will be questions and examples in the lectures and tutorials to go through, so you won't have a problem with solving those. This is probably one of the easier parts of this set of um, cost estimating. Here, additional cost is where a lot of the, I would say, wordy part of the calculations take place, because the sort of questions that come up when you have to deal with additional costs have all of these involved in just one question. So maybe you might have remembered from when you guys did 2101, there will be that like last question that like compiled everything into one question, and it would like the working out would take like two like pages or so. These are the sort of stuff that you'll be working with when solving questions regarding like cost estimating with cost of labor, cost of owning equipment, and cost of operating equipment. So the sort of questions you come across with will combine fuel cost with service cost with repair cost, like all into one, and it's just jumbled in. I will show like an example later on as well. But yeah, like um, it's a bit taxing on the eyes to read all of that. So essentially, if you remember from 2101, the sort of process that you would follow to just do those calculations of like um, per rate per hour per kilometer, like those sort of things are still the same calculations, but just yeah, it's just one of those situations again. Um, like sometimes if for this additional cost in 3101, they may have you find these based on like a different calculation that like let's say they ask like the scenario would ask for about fuel price. Sorry, it will show you fuel price, but then you'll have to um, backtrack and then find the fuel cost yourself. Or otherwise, they may just like clump the cost of labor all into one, which works like really well for you. But other times, maybe they'll just say like um, overtime is its own value and then taxes is its own value. So then you would have to do that addition yourself, essentially. Um, yeah, this is one of those you will come across these sort of questions and you'll be like, oh, this is such a long ass question. So yeah, just be mindful of that. Module 6, earthwork and foundation cost estimation. This is where you'll be wondering like, why on earth am I learning about soil? If you guys did soil mechanics, it's not soil mechanics type questions, but it will seem very familiar. Um, but in general, the sort of like you're still going to be working with like simple math calculations. Like there's nothing too monstrous about the sort of stuff you'll be working in terms of earthwork and foundation cost estimation. So, just to give a brief overview of essentially um, soil volume change, there are three types of volume that you will be looking into in this part of the course. Bank volume is essentially the volume that you would see when you just go into a site that's not touched. Like it's natural, it's before excavation, no other factors, no other man-made factors have changed it. And so the units for that is BCM, which is acronym for bank cubic meter. Loose volume is the like what like let's say if you did excavate that like um natural landscape, the volume that you like excavate is now loose volume because that has come loose and it's now with you. The units for that is LCM. Don't get confused with um, not to be confused with stuff like lowest common multiple. Like LCM means loose cubic meter, and then compacted volume is when you compact obviously that loose volume. And the units for that are CCM, compacted cubic meter. Majority of the time in this course, you will be dealing more so with BCM rather than the other two. You might see LCM here and there, but yeah, I think it's just a little bit easier on the head to have. Like I think yeah, most of the scenarios will be BCM, but if there is LCM, well, yeah, you know what it means now. Swell and shrinkage are two terms that may come up, may not come up. Like it still exists. You may be asked about swell and shrinkage, but you'll definitely have access to these formulas, which is essentially what you need to use. Like if a question asks about like if it will explicitly ask about swell or explicitly ask about shrinkage, So you could just immediately apply these formulas accordingly based on what the question is asking for, based off what calculations you require. And then, yeah, you'll be able to just plug these in, and that is essentially, yeah, your swell and shrinkage. Um, and then, yeah, on the right is just conversions for between BCM, LCM, and CCM. Those aren't required as much, but are still useful if you need to convert between the two. That is the conversion required. All right. Um, this is the more mathsy part of the earthwork estimations. So when coming back to like the situations where like you're working on a project and you need to calculate like the costs and um the time required, like these are the stuff that you'll still use for this question, but it's now just all about like the earthwork equipment. So the excavators, the trucks, the loaders, like these are the equipment that are being used just purely for earthwork. So these sort of questions will only look into those sort of equipment and its associated like timing, costs, preparation, like those sort of things. So when you're looking at these equipment, the cycle time, you will need to take into account all of these factors. So the loading time, the hauling time, offloading and returning. Sometimes the questions will only have like two or three of them. So you need to be able to know how to calculate the third and fourth, for example. Yeah, for example, like they'll only maybe tell you the hauling time, but then you should be able to know that the like truck would also need to return as well. So you need to calculate the returning time as well. Production rate generally is most of the time meters cube per hour. This is like how quickly the like soil or load can be transported between equipment to equipment or from equipment to like storage facility. And yeah, it's just a factor. It's just a rate. It's easily plugged into your calculations. Time factor, also known as working time, essentially how efficient the workers are at doing their job, or as me and my friends like to say, how lazy the workers are. So if the workers are able to only work 45 minutes for a given hour, then you would also need to factor that into your calculations. So that's essentially saying that every process that is done, like it's like the general rule in terms of the numbers that are given in the question, they're all assumed that workers are working like 60 minutes for that hour. But like, you know, it's Australia. You're allowed to work a bit. You don't have to work all of the 60 minutes. So, and take into account the actual working time, which generally is 45 minutes per hour. Um, I I think might have seen like a 50-minute per hour, maybe a 40-minute per hour here and there. But most of the time, just to make the math easy, it's just 45 minutes per hour. So then that, yeah, you'll just like chuck in that 0.75 times whatever that time is into your calculations. Um, and then you'll be able to, um, yeah, get that question with that time factor in place. Um, Doing the calculations for the actual volumes of soil is dependent on obviously the shape of the soil that you're looking at. So if you're looking at, let's say, a pit, for example, that has a horizontal surface area when you excavate it. So the way to work out that volume is the cross-sectional area times the depth. But if you're looking at a trench, for example, the cross-sectional area of a trench is vertical. So just remember that you're doing the cross-sectional area times the length of that trench. just so that you're not confused between if the question says depth versus length, you know which scenario you're working with. And then there will be questions here and there about the where the soil is in sort of like a trapezoidal mound. You might have seen these in like the industrial sites with like soil, like really like lots of soil, and it's kind of in the shape of a trapezium, like a trapezoidal prism. And so the way that you would like calculate that is by using the trapezoidal rule multiplied by the length of that like trapezoidal prism. Um, and so that's when, yeah, you would use those calculations there. There's lots of practice with that sort of scenario in the workshop questions as well. So you'll be able to work with that. Another scenario that could be given, I currently don't have a good example to give, but there is, I think, a question in the tutorial slides about it. It talks about like having a grid with like different depths at different points. So like, sorry, different like depths at different points. So then the best way to work with it is from a grid. And with that grid, you'll then be able to calculate like the volume based on the differing sets of depth. But then when you're doing those calculations, there's some rules that you'll need to follow. And yeah, those are laid out in the workshop solutions and will also be said in the lecture slides when Mosen talks about it. All right, mass diagram. This is just a like visual representation of the different like um, like regions where soil is located. Generally, you yourself don't have to draw the mass diagram. That's normally just already drawn for you in the question, and then it's just there as a visual guide to help you visualize, okay, this is the sort of profile that I'll be looking at. But yeah, the stuff that the sites that you'll be analyzing just very simplified. Like it's not like you don't have to worry about like buildings in the way or those sort of things. It's just soil versus like the datum, the road profile, the sea level. Like that's all you're comparing it to. Um, and then the sort of questions that you'll be provided are more so just comparing the cut versus fill. So cut is what has been excavated out of that region and then placed above the road profile, for example. And then fill obviously is the opposite, where that area is below the road profile um, and it's like the area that would need to be filled in order for that part of Earth to reach like the sea level datum or road profile. And then yeah, the methods to like just work out the like quantity or like the size of those cut area and fill area is to do like a cumulative addition of each of those regions and then being able to just just calculate each area. There is a set of calculations that will be explained in the lectures as well as written out in the workshop solutions. So those will give you a better idea of how to do those calculations, how to find the cut area, how to find the fill area, and also there may be instances where you need to compare the cut area to the fill area to then ultimately describe like if there is an excess amount of soil in the area or if like more soil would need to be essentially transported into the site, for example. Finally, for earthworks, there's also the items of shoring and piles. So shoring isn't really a verb as such, it's just a process. And in this case, shoring is actually the structure itself, that the structure that holds soil in place during a site excavation process. As you can see from the picture on the like top right, um, that's a timber frame. You're mostly working with timber shoring frames, like doing calculations based off that. The calculations that you would be working with for shoring are to actually find the cost to build a shoring system. This is going back to like material costs from the economics part and the cost estimating part of the course. So it's like a mix between modules for that sort of question. So yeah, we just need to find out the cost of the uprights, the wales, and the cross braces, which are labeled in the picture on the right. Um, I believe there are like some tricks that like can come up in the question with like the design measurements versus the actual measurements, for example. Um, I can't remember off the top of my head which one you take, but I believe most of them will go through that in the lecture. But just be wary of that because sometimes like the question gives you both, and you're like, oh, which one do I choose? Um, so if I recall, I believe it should be like the actual value. Like you don't have to worry. Like don't worry about the design measurements. Just go with the actual because I think you would have to choose the excess material rather than going off the smaller values. Like it's better to go with excess so that you can always just like cut off more rather than having a small value and then like oh shit like we have to add more. Um, so yeah, you'll be working more with timber. So they have their own set of costs, set of stuff that will be provided in the question when you're working with that. Piles also can be asked. They normally come in the form of like a steel piles in sort of questions. But if you didn't know already, piles are just columns driven deep into the soil so that the, the particular like, load, building, or structure is like situated on a more like a better foundation because sometimes like the immediate layer of soil is like really like too weak. So if you just like keep like digging, you'll ultimately find much more denser, much more compacted, um, stronger like part of the earth where we'll be able to lay that foundation there and then work based off the piles that you have put on. And then yeah, like you'll also come across in questions having to calculate how much piles you would need in terms of cost, not so much actually calculating how many the quantity of piles, because that will probably be given in the question anyway, at least for this course. All right, so modules 1 to 6 has pretty much the bulk of the maths. Modules 7 and 8 is literally theory. There's like, yeah, I don't think there's any math at all. So this is all just to do with the aspects of like there will be like parts like with research that most of them will go through about like types of safety and the responsibilities. Like these are all stuff that most of them would have done research on and put into his slides. Your job essentially with Module 7, Module 8 is to just have an understanding of these, and when the questions come around, you should be able to refer to these examples, scenarios, content, theory, and just like answer the question accordingly. So Module 7 is specifically to deal with construction safety and quality management. So yeah, there's a lot about safety in this Module 7. We'll go through it now. So two words that you'll come up that will come up very often um, when you're doing these sort of safety questions is due diligence. Um, and essentially, what that means is, sorry, is to taking the reasonable steps. And what that means is being able to know what WHS is, understanding the risks that are associated with like the project that you're working on, being able to manage the information that you know about eliminating those risks previously identified, and being able to manage that information appropriately, being able to comply with duties and like the implementation of the process to do so, and also being able to verify the effectiveness of resources used to do the above, or any other like anything that's related to safety, like those associated resources. Um, there's also there's so much other stuff that Mosin goes through with in regards to safety. And WHS wise, I've condensed it all into essentially due diligence. That's the sort of um, like definition that would be asked about the most. But like I would still recommend to go through the other parts of Module 7 in terms of health and safety when Mosin does talk about it, because there's probably something niche that he goes through. It could be us in the final exam, who knows? And I don't want you to like just like be like, I was like focusing too much on due diligence. So I still would recommend you go through like the lecture slides, the associated workshop questions, with the other stuff that is part of Module 7. And then also, just to add on, some of the, you'll probably be familiar with some of the important documents regarding safety. Um, Australian Standards is probably the one you're mostly familiar with, as well as Building Code of Australia. But yeah, the others, like state and territory acts and regulations, are some things that you could quote in the questions that are given, or depending on, or like if the question specifically asks for that, you don't need to actually quote the act itself because you're not expected to know the contents of these acts and regulations. But let's say if there's a question that gives like an excerpt from an act or regulation, you should be able to analyze that and um, like explain how that relates to like an unsafe construction situation, for example, if that sort of question comes up. And then also on the right hand side, we have preventing construction accidents. These are some examples. SWMS stands for Safe Work Method Statements. I believe off the top of my head, there's like 18 sort of roles and responsibilities that are required for that. I could be wrong. But yeah, those four are essentially the stuff that you would take into consideration to be able to prevent construction accidents. So that's just something to keep in mind, and also to explain depending on the, if a question or scenario was to come up and ask about that. This slide here is just to remind you that well, it's talked about in the lectures and that, but it's just if you were tasked with explaining the sort of reasons as to why it's important to take note of customers, this is essentially the reason why. You would need to know that companies need to take into account what their clients are asking them about, and they also need to still take into account their own safety. Like if their own safety, like if the client is asking the company to do a risky job, the company, like construction company, should be able to then also take into account, like know that this taking this risk will result in these like faults or concerns, and so that sort of stuff will need to be raised with the customer, for example. Um, but yeah, this slide is just to show that customer care is still really important when it comes to like dealing with customers. Um, so yeah, I'll move on. Okay, this is important. This is something that will definitely come up in a like wordy related question. Knowing the difference between quality assurance and quality control, there is a lot to distinguish the two. But if we were to summarize the difference between the two, I would probably say that quality assurance is more to do with like taking care of a situation or problem in a more passive way. But then quality control is like, yeah, you're being more controlling of the quality. And so that's where you're being more active with the sort of care that you're putting into the sort of actions that you're taking. So, yeah, for example, you might be able to tell that, like, sure, quality assurance helps establish the process, but quality control is where you implement the process. And so, in essence, um, like both are being used by companies. Like they will both use quality assurance at some point and then also quality control at some point. But there is a difference, and that difference is required at different stages, different scenarios, different phases of that, like a company's dealings with situations. So there will be questions that will ask maybe about just quality assurance, for example. So in that case, you may want to stay clear of explaining about quality control because it may not apply to that scenario, for example. Yeah, there's all the other details there. I think the lecture slides also have some other stuff, but majority of it is in this table here to look at. All right, final module is to do with ethics and risk, but looking at these from an engineering perspective. Now, you may be familiar with risk assessments, risk analysis. These will be very familiar. There's not much extra going on in terms of risk assessments, but probably the more newer stuff that you would be introduced to is Engineers Australia's codes of ethics, as well as project risk management processes and planning risk responses. So that's why I go through this last module. So these are the 4 code of ethics that are talked about in this course. I have essentially copy pasted their sort of descriptions. So for demonstrate integrity, for example, um, like the individual should be able to act on the basis of a well-informed conscience, be honest and trustworthy, and also respect the dignity of all persons. And then that also then, like for practice competently, has its own things, and exercise leadership and promote sustainability are also other like ethics that like an individual, like an engineer, should also take into account. There's other deeper explanations as to like a better breakdown of each of these um, descriptions within the lecture slides as well. Project risk management processes. So this is like the chronological order of to go from just planning the risk management to then being able to then control the risks, because you can't immediately go there. You have to go through those initial like the middle processes. And so yeah, it's like every individual should know that this is the sort of timeline you should procedure to go through from plan risk management to identify risks to perform qualitative to quantitative planning risk responses and then control risk. But it's not the responsibility of every engineer to follow up on that. That's more so for like the senior management or like the project manager. That's their primary concern, to ensure that this is being strictly followed when going from like the risk to controlling the risk. So um, yeah, this is we'll be going through the risk analyses, the risk responses, and identifying risks also later on in the following slides. But yeah, that's the general like procedure. Like it doesn't really deviate from that as much or at all, I think. So I'm sure like a good few of you would be very familiar with this matrix, risk assessment matrix. This is literally used for risk management plans. It's used to describe all sorts of risks. And although this is not the standard one, there is, I believe, like a standard risk assessment matrix that like you need to follow. Like there'll at least be a matrix for like one project, and that matrix would need to be used for everyone needs to use that matrix. The way to read these risk assessment matrix is it's generally like impact or severity on the um, on one axis, and the other axis is the probability or likelihood of that like risk happening. So for example, like impact or severity axis would be like, let's say if that risk was to affect the timeline of the project, like will the duration of the um, will the duration of the project like increase slightly or increase sorry will it increase slightly, like for example a couple days, or will it increase like a lot, like a couple years? So if it was a couple years, then it will be a very high impact on the timeline of the project. And then also the probability or likelihood side is, like, will that risk, like the likelihood of that risk happening. So if it's an unavoidable risk, then yeah, it will be a very high probability of occurring. Um, and then, yeah, obviously the opposite for the opposite scenario. Risk analysis, there's two types as shown in the procedure to follow. Qualitative is pretty much looking at the structural environment and then basing off that any sort of analysis that you would want to do based off what you see. And that can be done, that analysis is just done through like visual representations such as the matrix, and also risk categorization as well. Like if there was a scale of like on a scale of 1 to 10, how would you rate the like severity of the risk? Like instead of using the matrix, you can just use a scale, like that sort of categorization. But then obviously, yeah, if you wanted a more like detailed, like something more universal, you would then use a quantitative risk analysis, where you'll be able to exactly pinpoint like the exact severity or the exact likelihood of that particular risk happening. And that also can affect, let's say, the financial aspects of the project. So then you can directly relate that into the project's finances, for example. Like you can do like a factor of, like, let's say the probability of something is like a particular decimal or fraction that you can then incorporate into the calculations of the project's finances. And then that will change the finances of that project accordingly, which then gives a really, really, really good idea of how good or bad the situation has become as a result of that identified risk. And that's generally why in that process and procedure, that quantitative comes after qualitative, because qualitative, you get like an overall general idea of what's going on. And if there's like a huge, huge problem, then you don't really want to waste your time working out the quantitative results. You will just, if you can solve the problem qualitatively, then that's like really good, because it's normally done quick, easy, and it's like shows improvement um, from the outside as well. But when you're doing quantitative, that's more inside work, and you have to do a lot of calculations. It's hard, tedious. Yeah, you prefer to solve problems when it's like early on and what you can see as well. So the actual quantitative risk analyses are actually talked about in the lecture as well. They give like questions on the sort of analysis you need to do, and then the lecture and also the tutorial shows how to solve those sort of questions based off the analysis that is required for each. So that's risk analysis. And then finally, planning risk responses. So, sorry, this is where you will be able to tell based off the opportunities and threats. So you might be familiar with like SWOT analysis. So this is where we're just looking at the opportunities and threats that a risk can pose to a project. So yeah, like even though something can be a risk, it can still be a good risk and therefore an opportunity. So this is when, if you maybe had access to new technology, for example, that can maybe speed up the process of the project, where that use of new technology can replace old technology that was making the project run behind schedule, for example. Other opportunities that you can like take advantage of when doing a project is, let's say for example, there's a stable financial condition with like I don't know, globally or just within the project itself. That's when you can make decisions within your team to then say, okay, we can like take the risk of investing in a particular set of equipment, which won't, I don't know, depreciate as bad as if it was like a volatile financial condition. And so it would be just safer to buy this, like, I don't know, excavator and then work with that rather than buying it at a different time. And then obviously, you can also take advantage of the weather. If you have like a situation that's like perfect for drying, I don't know, particular material, then obviously that's when you take the chance. And then, obviously, the threats are where it's pretty much the opposite scenario. Um, there's also the added threat of just the workers' health and safety, which, like, for example, if, let's say, the construction site was next to a power plant or an environmental biohazard, then you would need to take into consideration the workers, like what sort of PPE the workers would need to wear. And when you're dealing with these sort of questions, in terms of risk response, when you're dealing with these sort of questions in exams and tasks, yeah, these are the sort of ideas you would need to think about, like what sort of PPE, like whether a PPE is required based on the situation, for example. Um, and then, yeah, on the right hand side is just the sort of stages that you would need to follow for each of like the positive risks and the negative risks. and um, like let's say for example in the negative risks um, picture, you would first try and avoid the um, like having to take on that risk, because obviously if you know that it's going to be negative, if you know it's going to pose a threat, then why would you want to take it on? But then if you have to, you just keep on going. Like you try, if you can't avoid it, then try and transfer it. If you can't transfer it, try and mitigate it. But if all fails, then you just probably just have to accept it. Um, and yeah, like you'll be able to sense what sort of response you would need based on the severity or level of threat that is associated with it, or level of opportunity that is associated with that risk. And that's also sort of like detailed from most in the lectures and tutorials as well, like what sort of stage you should be looking at for the different types of responses. So that is all the content of the entire course in one crash course. As I said, I've tried to condense it because there is a generous amount of content in this course. But there's also the chance that I have missed some components that most of them will go through in much more detail during lectures. So just keep an eye out for that and take the appropriate notes in addition to what you have listened to from me in this crash course. Just to finish up with the sort of questions you may come up or see in the final exam, because now we're looking more so into module 4, 5, 6, 7, 8 are still likely to come up in the final, not so much the midterm. So yeah, these question you can tell from this slide that the top left-hand corner is to deal with the contract types. So I've chosen here, for example, part E, which was to do with the CPIF contract. And then bottom right is a PDS question, where here you have to be able to recognize which PDS system is relevant to which situation. Again, both these questions have their respective solutions in the workshop solutions, so just feel free to read through that. They both have like decently worked out solutions that are quite easy to follow. But if there is any like questions you have regarding like explanations of it, I guess you're more than welcome to just send a message into maybe one of the group chats, or ask your friend, ask the lecturer. Yeah, Mosin is actually like really responsive and does give like decent feedback with questions and stuff. So I definitely recommend reaching out to Mosin if you do have questions, because yeah, he's pretty good. Not yeah, like he's not the best, but does the job pretty well. Yeah. And then for module 5 type questions, yeah, so question 2 is where your ENR indexes come into play, and you do the calculations based. In this case, you have to do both and take into account both the year adjustment and the location adjustment to ultimately determine the total conceptual cost. And then, yeah, question 4 is one of those the wordy question, um, where you have to be able to find out the information as quickly as possible and be able to calculate based on each of the different scenarios. So for like, I can break down question 4 with the different types. So different types of costs and production times and that. So generally how I would go about doing these sort of questions, because there is a chance that even the question 4 looks like small, there may be a chance that in the final exam there is like a question that has like double the amount of information in that. So if you were to come across a question like question four, or maybe even larger than question four, um, generally the way that I would look at this question is try and like just find the numbers because they stand out really well in like the massive block of text. So just look at the numbers and then it's like neighboring words to know what those numbers are talking about and just essentially just write them down in a list. That's at least the way that I would go about solving those type of questions because it just removes all the other junk regarding that. Like, yes, maybe some of it will need to still be described in like one sentence. But if there's a process that works for you, where instead of writing a sentence, like maybe like one symbol will be able to describe that, that will still help you very well instead of having to still search for everything in that paragraph. Because yeah, that paragraph is like really taxing on the eyes. Um, it's like doing a find a word with that sort of length of paragraph. Um, and then yeah, but like again, everything is still within that everything in that paragraph is exactly what you need. So like because I don't think there really is a formula sheet for this course, so you don't need to bring in any extra numbers into these sort of calculations. It's all there. All you need to do is sort it out, figure out what the hell the question is asking about. So, for example, question four is asking the quantity of fuel consumed in an hour. So, you would base your calculations off that. Like, for example, you would like keep everything in hours, like if they were um, related to, um, I don't know, like for example, 45 minutes in an hour, like you would keep that ratio in hours as much as possible. I know, for example, like it says cycle operation lasts for 22 seconds and rated capacity while filling the bucket for 7 seconds. Like maybe keep those as seconds. Like there would be a bit um, stupid to convert that into hours, but obviously it's there for a reason to be able to use that as seconds, and then ultimately that will then lead into a calculation based on hours, which then you can use to solve the question much simpler, and not have mass like random decimal numbers flying around that you can't really keep a track of. Like you probably heard from other when doing other courses, like having to convert from pascals to newtons per millimeters. Like those sort of calculations can really do your head in as well. So try and keep things as simple as possible. Stuff that works for you. Stuff that um, you can figure out even if in the stress of an exam environment. Um, yeah. Um, yeah, stuff like question four shouldn't stump you. Like they're there just to work through. Yes, it may take 2 pages work of working out, but it's still just step by step process. Um, yeah. Module six type of questions. So this is where when I was talking about how they give the diagram to you for a mass diagram, that's what I mean. You don't need to really be drawing your own unless you want to do like other annotations. So you would draw like the diagram again. Um, but yeah, everything generally is in the question. Like question three, I can tell you right now, was a previous exam question. So um, it's it may be in the workshop solutions. I'm not entirely sure. Um, but yeah, it's pretty much the sort of question you will get in the final exam if you were to get an earthwork type question where you would need to find the cut, the fill, and then as I was saying, like, is there like weight, like excess? Is there waste, or do you need to borrow from elsewhere to fill in like the required like area, the volume of that like site? And then, yes, similarly, for the question four in this slide, this is where they give you like all sorts of measurements for like the timber in like a shoring system. So you just need to be able to know which one is the correct value and work with that because like as I said, the question gives you everything, but sometimes they give you too much information. So you should be able to know which one's the correct set of information. And then yeah, again, question four also specifies other costs and production rates and um, yeah, equipment material costs. So that also needs to be calculated. Um, I think the question is asking for I don't think yeah, estimate the cost of installing a timber shoring system. Yeah. So that's the question that will also include the material and equipment costs. So that's where that comes in. I couldn't really find a module 7 type question in the tutorials that I would think would come up in the exam. Like that was still very like tutorial, like okay, you work through it in the tutorial, not so much in an exam environment. But yeah, I came across this sort of question on I think Course Hero, and they like the picture was locked, so I just took a random picture from online. But this is a sort of like scenario where you would be given a set of working conditions, and you'd be like, okay, what would you recommend to prevent like any sort of unsafe practices? Or like you'll be given like a set of unsafe practices and then have to identify the set of like um, precautions that need to be taken as a result. Um, and so I don't think there'll be any other different types of questions from Module 7, but I'm sure most of them will go through examples in the lectures for Module 7 type questions. And then Module 8 sort of questions come in the form of these two. Um, I know for a fact that question 2 on this slide was also a past exam question. So again, I'm not entirely sure if it's in the tutorials this year or not, but yeah, it's good practice to go through these sort of questions that I have put up in these slides. And then yeah, question 4 also I've just put in to also show that you also may have to do some sort of like probability impact analysis. Like maybe you don't have to do an entire matrix for it, but you should be able to know the difference, like the results that a risk can pose to like the probability or sorry, the risk can pose to the probability of the like let's say the project running over time, for example. So yeah, to wrap up this crash course, have been speaking for a decent while now, but the final tips and tricks that I did want to go through, you've heard it too many times. Sorry for repeating it, but practice is so important with this course because, as you probably may have known, or as I've told you multiple times, questions can be deceptively short. So they like the question itself can be like 3-4 lines, but the actual working out is 3-4 pages. So if you are able to practice these sort of questions, because there's like Merson puts out like a decent set of like activity style questions that you can work through, and there's always the tutorial questions that you can go through. And you should be able to work through these questions at a pace that's comfortable for you, but then also through practice be able to get quicker with these sort of questions so that you're not stuck dilly-dallying on stuff that is like repetitive. Like being able to do a bunch of calculations should be just second nature to you. And you can focus your attention more so on trying to like, I don't know, analyze a mass diagram, for example, which on first look can be quite intimidating. Um, so yeah, just try and find a way. Oh yeah, workshop questions are like, as I said, like even some of the workshop questions that I took to put in these slides were actually past exam questions. So I would highly recommend just like, even if you don't go through all the workshop questions in the workshops, go through them outside of class because they are really relevant and can help you do the questions if like, because even like the fact that the exams are final exams open book can bring your solutions to the workshop straight into class, and oh my days, you are set. Yeah, so just try and find a way to that works best for you. Okay, yes, there is a lot of theory, but again, final exams probably open book, so please don't try and memorize everything in this course. It's really, really hard to keep that all in your head, especially, let's say, if you are doing 3202 this term. I know that some of you are, and I, yeah, you need that brain power for that course. So try and like find a way that works for you to be able to work efficiently with this course. And this course definitely does reward effort though. So you don't need to remember as much, but you should be able to do stuff well. Like everything should be second nature with this course. You should be able to just work through it. Um, yeah. Um, One final thing, in terms of tips and tricks for the assessment. So when I say try to choose a project that is well documented on for the assignment, that just helps with not having to like ask for classified information. Um, may or may not be telling this from experience, but essentially, if you are choosing a project, try and find one that has a lot of stuff documented online, um, and you are able to like work on like throughout. Like it's not like a case where you have to email people for situations like, because they may not get back to you and you start stressing out with like, what the hell do I do with this assignment? But if in the case that you end up doing a project that does have like classified information, or you may not be able to get all the information you need, that's still fine with Mosin. He will still allow, like, he'll tell you what to do. Like, you won't get stuck or anything. But if you were able to pick a like particular project, just go for one that has everything on there. That's just my recommendation to go with that. Um, and then yeah, like the assignment itself can like take time. Um, like if you do want a good mark, don't leave it to the last minute, because there are lots of components to the assignment that if you do it last minute, you're gonna yeah, probably mess something up. So just yeah, get it. Um, when you can, just start on it and work through it at your own pace, and yeah, you'll be completely fine for assessments as well. Well, that brings the end to the crash course. Thank you very much for your attention, and I wish you all the best with your studies for this term, and all the best with 3101. Thank you.